dried out before it had a chance to decay. Animals gather around a water hole in Namibia, southern Africa. Blowing in the wind. Deserts are in permanent drought, and so most are covered in dry sand or sandy soil. The wind can blow dry sand grains around, causing sandstorms. Sandstorms create sand dunes, which make up much of the landscape of the hottest deserts. We had a sandstorm coming in from, oh gosh, where was it? The Sahara Desert. We're supposed to hit the United States today, I think, in the southern states. We had a little bit come this way, supposed to have been here Tuesday, which was yesterday. So that's interesting. I want to look that up again. Black blizzards. In the 1930s, the Great Plains of the North American Midwest suffered severe drought. Grasses in the fields had been plowed, so the topsoil drained to dust and blew away in clouds. Thousands left their homes, and some died of starvation or lung disease from inhaling the dust. This is why we use regenerative practices here on our homestead, because if you don't have that soil connection and root systems going on, this can happen. And it depletes the soil nutrients and everything. All the topsoil is gone, just blew away. Thirsty leaves. In the dry lands of southwest Africa, the kokerboom tree can survive several years of drought. Its leaves shrink, having lost most of their moisture. Cracking up. Man, here, like, the ground can crack. Like, we could have rain and lots of rain, but then like 3 days later, the soil's like cracked, like in our walking paths, so where we're not using regenerative practices with wood chips and stuff. So it's really interesting. Large areas of land with no vegetation quickly suffer from drought. Yep, that's true. No plants means no water store and no protection from winds that increase evaporation from the soil. Water helps bind soil grains. Dry mud cracks because becomes brittle and produces dust. Lake Naivasha in Kenya, Africa, dried up from a drought. All right, I think I read all the things on that. Polar extremes. The northern and south poles are frozen all year round because they receive little sunlight. Around the North Pole, the Arctic has no land, only thick ice. Around the South Pole, Antarctica's land is constantly covered by snow. Strong winds in Antarctica are caused when cold air flows off steep slopes, blowing snow into a blinding blizzard. Temperatures peak at negative 40 degrees Fahrenheit, negative 40 degrees Celsius during the long, dark polar winters. The polar regions and their cold currents are important for global weather. I need to get a drink again, guys. Sorry. Ice station. During summer, polar research stations house nearly 4,000 people at 42 sites. Less than 1,000 people live there in winter. By studying the weather at the poles, scientists can learn more about the Earth's weather patterns. Get a grip. Climbing boots have a thermal lining and pants clip to the tops of the boots to help retain body heat in icy conditions. Crampons spikes on the soles provide grip. Tough and durable plastic outer layer. Spikes help to grip thick, slippery ice. Okay. Breaking the ice. During winter, when huge amounts of sea ice form, powerful ice-breaking ships keep waterways clear, transport vital supplies, and our research stations. Eye protection. Goggles protect eyes from the glare of sunlight, which is reflected by the snow. Weather station. There are automatic weather stations across the polar regions. Forecasting the weather is important for the safety of those who live and work in these hostile environments. Fly the flag. Newly fallen snow and blizzards can bury important items. Some people plant colored flags to help them find their tents and supplies. Pyramid tent to withstand high-speed blizzard winds. Weather balloon for gathering data about the atmosphere. Weather balloon. Equipment in this weather balloon measures the temperature and concentration of gases in the Antarctic atmosphere. These measurements help scientists test theories and make more accurate forecasts. Warm up. In polar climates, extreme cold weather outfits cover the body. Outer layers include waterproof jacket and overalls made up of several layers of different materials, the best way to reduce heat loss. Elastic cuffs keep out icy winds. Bright red color makes the jacket stand out in a blizzard. Bib overalls underneath. Where am I now? Time freeze. Much of the ice at the poles has been frozen for millions of years. We don't believe that. It preserves things that were around when it froze. By studying samples, scientists can discover what the climate was like many years ago. Staying alive. Multi-layered gloves protect hands, which are at most risk from freezing conditions, as the body shuts off blood to them to reduce heat loss. Severe conditions can cause frostbite. Scientists in Antarctica use a drill to extract samples from the sea ice. Weather watch. With enough warning that a hurricane is going to hit, many deaths can be avoided. Hurricanes can be tracked using weather satellites, but other types of extreme weather require ground-based measurements, including wind speed, temperature, and atmospheric pressure. The data are recorded using instruments around the world on land and at sea. Forecasters use computers to analyze data and to predict how the weather will behave. The most difficult to predict are short-lived phenomena like tornadoes and long-term conditions such as drought. High in the sky. Balloons are essential to weather forecasting. They carry instruments into Earth's atmosphere and transmit readings by radio. Measurements of upper atmosphere conditions are important for predicting what the weather may do next, and for discovering more about how the weather works. About 400 bumpy projections help to stabilize this balloon while in flight. Doppler radar dome. Round radar. Sensitive radar equipment enables weather scientists to make more accurate forecasts. The U.S. National Weather Service relies on ground-based Doppler radar stations to measure wind speeds and rainfall and to calculate cloud positions. Here in Oklahoma, it's the National Weather Service of Norman. Working with the weather, a modern weather forecast involves countless measurements of temperature, air pressure, and rainfall, plus complicated mathematics. No wonder computers are used, although humans are needed to interpret it all. Signs from space. Geostationary satellites hover in space about 22,500 miles, 36,000 kilometers above the equator. They record atmospheric temperatures and cloud patterns of a particular region on Earth. Solar cells power the Meadowstate satellite. Satellite view. Okay. Doppler radar dome. Satellite view. Infrared is heat radiation. It is not visible to human eyes, but can be detected by special cameras. The warmer something is, the more infrared it produces. A satellite picture like this helps meteorologists to measure temperature across the world's surface. From far afield. This automatic weather station is in the middle of a field. It gathers measurements of wind speed and direction, temperature, humidity, and sunlight. The more data that meteorologists can collect, the better their forecast will be. Instrument for recording wind speed and direction. A meteorologist downloads weather data to his portable computer. That is a very old computer. Oh my. Hurricane hunter. These are under suspicion now, because it's very interesting that hurricanes don't happen until after these hurricane hunters go fly by. The meteorologists and instruments aboard this Lockheed WC-130 modified military transport airplane fly into hurricanes at an altitude of 2 miles, 33 kilometers, to help with accurate hurricane forecasts. A large tailplane gives greater stability at low speeds. Extra fuel is carried in tanks mounted on the wings. Propellers sustain less damage in a storm than jet engines. So they have propellers instead of jet engines. There it goes. The Geostationary Operational Environmental Satellite System, or GOES, is a series of satellites that monitor Earth's entire surface except the polar regions. This latest satellite, GOES 15, was launched on a Delta IV rocket from Cape Canaveral, Florida in 2010. Now we have Skynet going up. Tornado pump. Weather forecasts are available across the media, from newspapers to the internet, and gas pumps, such as this one in the U.S. A built-in screen shows tornado movements and announces warnings. Okay. Sea search. Buoys carry automatic weather stations. They drift in the sea for weeks, measuring wind speed, temperature, and humidity. It is important to monitor sea conditions because they greatly influence the Earth's climate. Satellite is carried in the rocket's nose cone. Disaster relief. Extreme weather phenomena such as storms, droughts, and floods can cause massive destruction. When this happens, people may need help to keep them alive and well, or somewhere to stay while their homes are being repaired or even rebuilt. Food and water supplies may be affected too. International aid agencies provide assistance, food, and medical supplies to those who suffer due to the weather. I think ours is Red Cross. Damage, demolition. This building was destroyed by a tornado. The governments of wealthy countries set aside emergency funds to pay for rebuilding work. Poorer countries often need outside aid. Cleanup operation following a tornado in Connecticut, October 1979. Mopping up. A priority in a flood is to drain excess water. Powerful pumps clear the streets. Sandbags protect properties from flood water and control the direction of the flow. Upturned lives. A rescuer searches for this upturned home following a tornado in Florida. People in the southwestern United States suffer many hurricanes and tornadoes, but they can never be fully prepared. While rebuilding occurs, people are housed temporarily. Portable water. During a flood, drinking water is often cut off or in short supply. This Filipino boy is collecting fresh water from a tank. Temporary water tank provides clean water to flood victims. Air meals. When a natural disaster strikes a remote location, the quickest way to bring aid is to drop supplies from the air. Each of the tightly bound packages from this airplane contain flour, oil, and canned fruit. It is difficult to drop water in these packages, even though it is often what is most needed. Makeshift shelters in a refugee camp in Ethiopia. Disease prevention. Epidemics rapidly break out in disaster sites, and they are a common cause of death. This aid worker is spraying insecticide to kill disease-spreading mosquitoes, insecticides that will not harm people when they filter into the water supply must be used. Temporary homes. When drought brought famine to Ethiopia in 1989, the United Nations set up a camp in Sidamo province, helping 45,000 people. Each family was given plastic sheeting as a temporary shelter, a sleeping mat, cooking utensils, food, and water. Refugees had to find their own cooking and building materials, putting a great strain on scarce resources. This is their emergency food falling. Yep, it's really interesting. All dried up. When this picture was taken, there had been no rain in the Suguta Valley, Kenya, for 7 years. Famine is common during a serious drought. particularly in remote areas with few supplies. This is why food aid from charities such as Oxfam is important. Nature's survivors. The world's plants and animals are well adapted to their environments. If they were not, they would soon die out, particularly in extreme climates such as deserts. Some living things are so well adapted to their surroundings that you might think they had been specially designed to live there. But living things adapt to their surroundings gradually over many generations. We kind of don't agree with that either. We believe God created everything the way that it was supposed to be created. That monster, the Gila monster, lives in Mexico and the southwestern United States. In the warm, rainy season, food is plentiful, and the Gila monster stores body fat on which it can live during the cold, dry winter. Useful tips. In a rainforest, about 3 feet 1 meter of rain falls each month during the rainy season. Plants depend on water to survive, but constantly wet leaves kill them. Some leaves develop drip tips to carry away the water. Drip tip of a rainforest leaf. Feather coat. Snowy owls live in Arctic regions. Their soft, fluffy feathers hold lots of air, which insulates them against the cold. They even have feathers around their claws. If the weather becomes hot, snowy owls cool themselves by spreading their wings and panting. And our chickens do that too. Upside down tree. According to myth, the strange-looking baobab tree angered the gods, who punished it by replanting it upside down. In reality, the tree has leaves for only 3 months a year, which, along with water stored in its huge trunk, enables the tree to survive East Africa's dry season. Stemming the flow. Excuse me. Leaves are covered with stomata, tiny holes, that allow water to escape. As it does so, more water is drawn from the soil by the plant. Where water is scarce, plants have fewer or smaller leaves. Many cacti have no leaves at all. There are simply large stems containing water. Fat stored in the tail provides energy in the winter for this Gila monster. Some like it wet. Like all frogs, red-eyed tree frogs have moist skin. If their skin dries out, they will die, and so tree frogs thrive in the damp rainforest. They also have suckers on their feet to climb along the branches. Underground movers. Most amphibians need to keep their skin moist during a drought. Many stay in burrows or a moist location. Like a rotting log during a dry season, some frogs become dormant, cocooning themselves in a moist mud. Water hump. In the constant drought of the desert, a camel can make water from its own body fat, using 1/4 of its body weight. Fluffy feathered chicks huddle for warmth. A camel can drink the equivalent of a bathtub full of water in just a few minutes. Wow. Australian burrowing frog. This is very interesting looking. In a cold climate, emperor penguins live in the harsh Antarctic all year round. Waterproof feathers and thick fat layers help them survive on land and in the icy seas. During winter, their fat body provides an essential energy source. Feet are small to minimize heat loss. Overlapping, closely packed feathers keep out fierce winds. Alrighty, I think we're going to stop there and we'll have to make another video. The next video will start with climate change, my most favorite subject. Bye.